All right, everybody. Thank you for joining our webinar today on Crossing the AI Valley of Death, where we'll talk about and discuss how you move your artificial intelligence, your data science algorithms and models out of the lab and into a production environment. A couple of notes before we get started here. I want to talk a little bit about what we will and won't be going through. We will be talking about the sort of things that you need to do in order to move your models from both a technical standpoint as well as a non-technical standpoint out of the lab into a production environment, but we won't necessarily be going into individual technologies or applications along the way. We feel that you really should use the technologies that you're most familiar with as you're trying to get your model through this journey between the lab and the production environment. So a little bit about me. My name is Clayton Davis. I am the head of data science at Monty. For those of you who are unfamiliar with Monty, we are an AI delivery platform that really focuses on what we call the last mile delivery of AI. So we've helped people who have AI models to get those models out of wherever they happen to be, perhaps a lab, and into a production environment where their end users can access them frequently and at scale and with monitoring and governance, all those sorts of things. As far as my background is concerned, I was a physicist, but I've spent the last, 15 years doing data science across the spectrum. Everything from Excel macros to petabyte level Spark analytics to deep learning style neural networks. So I've been in most of your shoes at some point in my career so far. So let's level set a little bit. What do I mean by the Valley of Death? When I say the Valley of Death, what I mean are all the obstacles that you encounter as you try to move something out of the lab into a production environment. The sort of concrete example I like to use is that of flying cars. Right? Flying cars capture the imagination. They solve a real world problem. And there are actual prototypes that exist of these things. And they've been around for several years. So on the surface, they look like a really good candidate for transitioning from the lab into, or the proof of concept phase into a production phase. But there are a host of problems associated with them, right? Regulations have to be figured out. Insurance needs to be figured out. There's more engineering that needs to happen, and obviously, the cost of flying cars is significantly more than a sort of standard automobile. And so, because of those things, regardless of whether or not there's a pull from people to go ahead and buy them, it's far from certain whether or not flying cars will ever move from just the prototype phase into something that's like mass produced that you could buy at your local Ford dealership. Right? In AI, when we think about the Valley of Death, what we think about are all of the obstacles that you have to overcome in going from the lab to production. Some of them are technical and they have to do with things like making sure the metrics are correct. But others are simply procedural or bureaucratic, trying to find the right server for your model to sit on. And so the Valley of Death in AI really looks like any time you built a model that had good performance metrics and a low computational time, but for whatever reason, it didn't make it from the lab out into a production environment. And our discussion today is going to help you better position the models that you create to traverse that Valley of Death and come out on the other side so that you can get your models from the lab into the production environment. So that brings up a good question, and it's just quite simply, what holds good ideas back? In my experience, there are three things that tend to hold people back, or hold the models back. One is building an effective team that's capable of functioning for an overall goal in a technical space. In this case, the goal being to move from the lab into a production environment, and from the beginning, when you're building models, thinking about the production environment. The second is empathy, trying to understand the request that you're making to move your model from the lab to a production environment has business implications, and you need to be able to put yourself in the stakeholders' shoes so that you know what you're asking from them in terms of the resources they have available to them, and so that you can make a compelling case as to why they should help champion the movement of your algorithm from the lab into a production environment to the good of the organization. And the third is process. The third is having a model ops process in place so that there is a repeatable way in which you can go from the lab out into the production environment. those three things constitute the vast majority of what holds good ideas back. And I think it sums up pretty well in one particular sentence. So if you don't remember anything else from this presentation, remember this one thing. As technical leaders, what tends to hold us back from transitioning our models from the lab into a production environment is that we think too much like IEEE and not enough like Harvard Business Review. You'll notice I have three things on here, and two of them are more aligned with human interactions than they are with any sort of technical problem or technical innovation that gets missed. And that's very much on purpose. In most of the cases I've seen where models failed to transition from the lab to the production environment, there wasn't necessarily a technical hurdle that needed to be overcome in that transition. And it's important that you think about these three things, the teamwork, empathy, and process, as none of them are panaceas. They have to actually work together, right? Putting together the right team and having them function provides for you a model that's worthy of being moved out and into production and has a high probability of success. Empathy and developing champions among the management chain, that helps clear away bureaucratic hurdles as well as policy hurdles so that your model has a good chance of being installed into the production systems and being capable of running there without being superseded by another priority. And finally, when you've got those two foundations in place, process kind of helps you build that bridge between your lab environment and your production environment and gives you a roadmap for you to be able to follow as you go from that lab to the production environment so that things that you do are repeatable and are easily modified in the future. So looking through them, you'll notice that I put teamwork at the beginning of the slide earlier. And that's because I feel like it's the most important thing when you're trying to develop a model that is going to be successful long-term in production. Okay. And the first thing that you need to recognize when you're going about building your team for building your model either in the lab or after you've built it in the lab and you're transitioning it into a production environment is that there are no unicorns, right? There is no data engineer / data scientist / DevOps engineer / Kubernetes expert / cloud architect. And so if you're wanting to really transition your model and your capability from the lab to your production environment, you're going to have to assemble a team of people that have all of those necessary skills in order to be able to make sure that your model, when it's available in a production environment, is robust and capable and performant. Now, talking about the joys of teamwork is become a little bit of a cliche, and so I'm just going to assume that we all are on the same page about needing a team and not being able to do all of this ourselves. But I will point out that there are three obstacles that I've encountered time and time again that you should be aware of and you should be looking out for as you're building a team. The first is a little counterintuitive, and it's actually just past success. So when we assemble teams, we go and we look for people who are, perhaps the best that we can find that are available to go ahead and put on our team as we're trying to transition, again, the model with the goal from the lab into the production environment. The problem with that occurs in that people, especially in technical disciplines, they tend to get rewarded and move up in their careers through individual contributions. And so their past successes can quickly make them rise to the go-to person for a particular item that you're interested in. But that doesn't necessarily mean that they've developed the skills that they need to work in an interdisciplinary fashion, and that they're able to kind of pull back when the good of the overall transition it needs them to. And so I'll give you an example. Data scientists typically tend to build models that are going to be as performant as they possibly can. They want really high accuracies, recalls, high precisions. But getting those really high values requires you to use models that have a significant number of parameters associated with them, which means that ultimately the model files become really, really huge, right? That's good for the data scientists and their particular slice of transition, which in this case, I guess, would be model development. It's not so good for the other people at the end of the transition path, the people in IT who are going to have to store that model, and they're going to have to swap that model in and out sort of on demand as users are going to want access to it. So what you have to instill within the team is the idea that what they're doing isn't necessarily to optimize their individual part of the development process. What you're after are a group of people who can excel at their individual aspect of the transition process, but can also pull back when they need to make sure that the overall ability to transition from the lab into a production environment and to be successful in the production environment is their main goal, right? That's what you're looking for. The second is trust, and that's just a common thing when you get a group of people together that have never worked together before. It takes time to develop an understanding between people and a trust that when a person A is asking for something from person B, that they see it more as a requirement and less as a nice to have, and know that the best interest of the team and the best interest of the transition is really what's driving their interactions. And the third is understanding. Teams function better when they can anticipate what the people around them are going to need. It is uncommon in my experience to have a data scientist really know what the IT manager needs, or really know what the Kubernetes site reliability engineer, for example, is going to need. And it's uncommon for the site reliability engineers to really understand the intricacies of the deep learning models or the AI models that they're being asked to make available to end users on a constant basis. And so at the end of the day, those three obstacles, if you can overcome them, that's what you're looking for. You're looking for a group of people who have a general, at least, understanding of where they fit in the overall team, where their role helps to further the goal of moving the model from the lab out into the production environment, and that have developed enough trust with each other that when one member of the team is asking another member of the team to make sure that a particular sort of parameter is met, that's seen as a reasonable requirement and not just an opinion about how the final product should look. All right, second to teamwork, I placed empathy on the list. And when I say empathy in this case, typically we think about putting ourselves in other people's shoes and the interactions to see how they're going to feel. And that's what I mean here, but perhaps in a slightly different context than most people are accustomed to thinking about it. What I mean when I say empathy is that you need to put yourself in the shoes of the stakeholders who you're going to be asking to give something up in order for you to be able to move your model from a lab environment into a production environment. Okay. Businesses only have three levers that they can actually pull: time, people, and money. If you are asking your organization to support you in moving your data science or your machine learning algorithm from the lab out into a production environment, you are asking people to give up either time, people, or money, right? You're asking your boss to allow you to work on this instead of whatever his other priority is. You're asking the CFO of your organization to spend money on new servers or new hardware or new technology. You're asking the IT manager of the production service, the production system and servers to set aside server components for you that may or may not have necessarily been in their budget. And so when you're going about trying to figure out what your transition plan is going to look like from the lab into a production environment, the most important thing you can do to get up the other side of that valley of death after you've produced your model is to have people on your side, stakeholders who are willing to say your transition from the lab into the production environment is important, who can help you figure out how to make sure that that transition occurs within policy and within compliance of the overall organization, and can speak up for you when there are competing priorities within the organization. Okay, so as long as you have your team established and the team is functioning well and you've spent time interacting with the stakeholders to get people on board with the idea that moving your model from the lab out into a production environment is the right thing to do for your organization, it's time to build that bridge between the lab and your production environment by going through a very sort of standardized process that you can repeat time and again for each of the models that you want to transition from your lab into your production environment. Now, this is essentially a model ops pipeline. I think about it in terms of 8 steps and 3 different phases, and so we're going to go through each of those now. So the first stage that we think about, or that I think about when I think about model ops, is really what I call the data science phase. I'm not going to spend a lot of time on this particular phase just because most of the people listening here, they've built models before, they understand what it means to data preparation, they understand what it means to train a model. But I am going to point out 2 particular aspects of this phase that tend to sneak up on people, and by addressing them early on, you can prevent quite a bit of headache later on. The first is the data preparation phase. When data scientists go about building models, the thing that they tend to do is go get a bunch of training data, validation data, and test data, and then kind of store it locally on their machines, right? This can be a problem in that later on in production, your data is not going to be sitting on a local file system somewhere that you've got access to and you've got complete control over, okay? What you should be doing in that early sort of data preparation phase is thinking about not just how you're going to get access to your data here while you're training your model. You should be thinking about how you're going to have to access that data later on in the process once you're sitting in a production server somewhere. And so at the very beginning, when we start engaging with whoever's doing the data collection and the data preparation on the team, you should also be engaging with the IT individuals who are going to be feeding you data during your actual production run. This will help prevent hiccups from occurring when, say, for example, you're building a model that does activity detection on video. Well, during the training scenario, it would be perfectly reasonable for you to go ahead and just read movies off of your local file system. But if the IT setup, if the intention in production is going to be for you to be accessing streaming camera feeds, well, then you need to know that ahead of time so that you can make your training process mimic that as much as possible during testing, and so that whatever software engineer is ultimately going to have to connect your model to that streaming feed, so that that person has the time to go ahead and start researching whatever sort of protocols they need to make sure that there is a seamless transition between data being fed into your model in the lab and data being made available to you in the production environment. The second thing that we need to talk about a little bit in the data science phase is model training. I talked about this a little bit before, but data scientists tend to try to make models that work as well as possible, right? We're always out there sort of chasing perfection, right? That's not necessarily the approach that is most useful or most beneficial when you're trying to build a production grade model, right? The thing that you're wanting to do is to build a model that is performant. So when you talk to stakeholders early on, as you were building your champions for moving your model from the lab off into a production environment, you should get a sense of what it is that they're expecting, how well they're expecting the model to be able to perform, and you should know ahead of time whether or not you'll be able to hit those sorts of accuracy, precision, recall style metrics along the way. If the requirement is, say, an 80% recall, right, then data scientists should spend their time getting to an 80% recall. They shouldn't spend their time chasing perfection at 99.99%, because doing so is going to create overly complicated models, and it's going to inhibit people later on your team as they try to transition that model into something that can be readily accessed and available. Okay, so once you have built your model, you got your training data, you built your model, it's meeting whatever your performance metrics are that were being expected by your stakeholders. What do you actually have at that point? What you actually have is a model that will run on some executed code that sits on your laptop somewhere or sits on a shared server of some sort. Right? But that's the only place that it'll run. The thing that you need to be focusing on now, if you haven't already, right, is getting that model and getting that code under some sort of versioning control software. At Modzy, we use Git, and we actually start this at the beginning of the process, but we found that quite a few people will go ahead and try out building their models, and only once they get to the point where a model is being deemed effective do they kind of transition into a version control scenario. But either way, once you get into a version control scenario, we get into part of the process that we call the model code versioning section of the machine learning engineering phase for our MLOps pipeline. And in this phase, what you're going to do is you're going to have someone from your team with software engineering experience come in, wrap your model in code so that it's not just a model anymore, but it's an actual application that can be called. There will be several things that they do, but sort of chief among them are going to be things like pre-processing of data, error handling, post-processing of data, making sure that the output that's coming out of your model is always a consistent format and reproducible. And so that software engineer effectively is going to take your model from being just a bit of code, maybe in a Jupyter notebook or something like that, to being an application that can be accessed on the command line with something like run model space input. Now, at the end of that process, you're still going to be in the model code versioning component of the MLOps pipeline, because what you have at that point is a model that's performant, can be passed data in pretty much any way that you want and will respond if things go poorly, but it can still probably only run on the software engineer's machine, right? What you actually need to do is get to the point where your model is wrapped in a software application that sits inside of a container image of some sort. Now, we use Docker, so I'm going to reference it in that way. But what ultimately that's going to require is a DevOps engineer coming in and writing, say, a Docker file that will take the application that the software engineer has written that contains the model that your data science team has put together, and with the use of that Docker file, you can have anyone who has access to a computer with access to that Git repo, pull down the Git repo, and then run the Docker file using the Docker daemon to generate an actual OCI compliant container in which will reside the software engineer's application that runs your model, and can now, because it's in a Docker container, run on any platform that has Docker installed on it, or has a suitable OCI compliant container runtime, like perhaps Containerd put onto it. And this is really the chunk that you're after here at the beginning of the MLOps pipeline. You have now a container; it's capable of running your model with the actual application to do some error handling and a well-defined output available in a package that can run out away from just the lab environment. And once you've gotten to that point manually, we move on to what we consider the next phase in the MLOps pipeline, which is creating automated builds. Okay? Automated builds are set up by putting together a pipeline within some sort of CI/CD server, continuous integration, continuous delivery server, whereby a third-party piece of software, it could be Jenkins, it could be CircleCI, or a couple others, watch your Git repo. And every time there is a change to your Git repo, what they do is they take the new code, they compile the new code into the new application, then they'll look at the Docker file, they'll automatically create a new Docker container that can run anywhere. And then once they have that new Docker container, they'll perform a series of QA checks on it to make sure that the container still functions in the way that you expect it to. And then they will actually transition the container for you over into what we consider to be the final part of the machine learning engineering phase, which is image distribution. Up until now, everything that you've been doing to build your model and to get your model ready for a production environment has happened within your lab environment. It's at this point in the image distribution phase where that container that you created that can run anywhere gets pushed out into a repo of some sort that your production system will be able to access. And this will be the first time that your production system is going to actually be able to access the model that you've been creating and that you've been carefully packaging up this entire time. All right, so once you've gotten that model sitting into some sort of Docker container repo, whether that happens to be AWS's Elastic Container Store, or Azure's equivalent, or just some local some local Docker repo managed by your IT department, we're really ready now to perform what we call the last mile delivery of your model. It is available to the production system, but now we need to make it discoverable. We need to make it performant. We need to make it able to scale and to be monitored. Okay. This is also the point at which some people will have gone ahead and just decided, you know what, I'm going to wrap this thing in a Flask app, and I'm just going to give it a web endpoint that my users will be able to hit, and we'll call it a day. I would caution you against that, because doing that is ultimately going to provide you less. It's not going to provide you the information that you need, and it's not going to be scalable. You're going to lose a lot of capability just by sticking a Flask app up on your local network. So let's talk about the way that I would go about it and the way that I recommend people go about actually deploying their models. So the first sort of process we go through in last mile delivery is the actual model deployment. Remember, up to this point, there is just simply a container sitting in a repo somewhere, and what you need to do is be able to move that container out of that repo and into a local server somewhere. And by local server, what I actually mean is a production server. And that's a fairly straightforward thing to do. You can just simply Docker pull the container out of the repo onto the production server that you intend to use. And at that point, the server can in fact run the model that you've developed in the lab, and you are actually kind of sitting on a production environment, but you are not done. The model is there on the server, and it requires at least 3 more things in the model development stage. The first thing that you need to do is make sure that that model is discoverable. There are millions of processes running on your network at your company or your organization that you know absolutely nothing about. And if your model is not discoverable by end users, it just becomes another one of those processes executing on the model. So whatever your company uses for knowledge management or coordination of resources, whether that's a wiki or whether that's SharePoint or some custom-made knowledge management software, you need to make sure that there's an entry there and a place that users would expect to be able to find it that details the fact that your model exists, where it exists, and how to get a hold of it. Right? In addition to that, the second thing you need to make sure of is that in that same location, there's documentation for how to access your model. The sort of input that your model expects, the sort of outputs that are going to be coming out of your model so the user knows what to expect coming back to it, along with just general understandings of error codes and examples that end users can see and then implement themselves. And the last thing you need to do before model deployment is complete is to make sure that only the appropriate users that you want to have access to your model actually have access to your model. That is actually not a data science function, right? That is an IT function. And so what you need to do is work with your IT department to make sure that if the model needs to be restricted from certain people, that it is in fact restricted. A lot of models are generally applicable, and there's not a reason necessarily to prevent other users from accessing them. But there are certain models that happen to be sensitive in nature. Say, for example, a model that predicts attrition for HR, right? Those sorts of models you wouldn't necessarily want to make available to everyone. And so by working with your IT department, you can make sure that only people who need access to a particular model get that access to a particular model. And at that point, we would consider model deployment to be complete. The model in a Docker container is running on a local Docker runtime in a production server. The model is discoverable by end users through whatever knowledge management sort of application an organization uses. Documentation exists that tells people what the model expects and what they can expect from the model. And the model's been restricted to only the users that should have access to the model itself. Now, with that model sitting on the production server and being available, you now technically should be able to perform production inference and to accept requests coming in from your user community and serving up outputs. But there are two things in particular that you need to focus on here in the production inference stage of our ModelOps pipeline. One is how data is going to be accessed. And this is a nuanced difference between the lab and the production environment. In the lab environment, you just uploaded whatever data you wanted into a local file system and then ran your model against it. But in a production environment, the actual data routing and input into your model and data routed out of your output isn't going to be controlled by you. It's going to be controlled by the IT department. And I haven't yet met an IT department that was comfortable with the idea that a user could upload any arbitrary sort of file onto their network and then just leave it there. And so in order to make sure that end users can actually access your model for production inference, you need to work with IT to establish the rules and how they're going to evaluate data that's being pushed into your model, being pushed up onto their network to be fed into your model. Once that has been worked out and IT is comfortable with the way in which data is being accepted and pushed back out from your model, then you need to move on to make sure that availability has been addressed. No one I know builds a data science or an AI model hoping that only a couple of people are going to use it. Most of the people I've encountered, they build models under the hope that it's going to be wildly successful. And under the assumption that it's going to be wildly successful, you need to make sure that the model that you have established in the production environment can handle a large amount of requests and users and handle surges in capacity. Typically, this means implementing some sort of auto-scaling functionality and having that available. In Modzy, we use Kubernetes clusters and some specialized scheduling under the hood to make sure that we can deal with increased demands for a single or multiple models. If you aren't necessarily using Modzy, then the thing that is easiest to do for a single model is to put together some sort of load balancing auto-scaling combination in a cloud provider like AWS, for instance. But regardless of how you do it, at the end of the production inference phase, right, you have a model. It's been wrapped in some sort of software application. It's sitting in a container so it can run outside of your lab environment. It's pulled up on a production environment. There is an accessible path for users to get access to it, and it auto scales to deal with spikes in user demands along the way. And you are finally ready to actually allow users to access your model through whatever setup you've worked out with IT. And now it's time to monitor that model. So you have a model available, it's churning through user requests, and what you're actually looking for at this point isn't when things go well. Hopefully at this point, 98% of the time when people use your model, it's going to go well. But there will be times when your model fails, and that is that's what you need to be keeping track of when you're doing your production monitoring in this last phase of the MLOps pipeline. Because when that model fails, that tells you something about your system that needs to be corrected. It could be that the model is failing because there was a software problem in programming, or it could be that the model is failing people because the training data wasn't inclusive of a particular category that just simply wasn't expected or thought up. Maybe there's been concept drift since that time. Whatever the reason, you need to make sure that in production, you're keeping track of, at a minimum, logs for the people who are using your model, what the result was in terms of just status when the model completes. Did it fail? Did it succeed? Are the people who are routinely getting failures when they're trying to access your model? And that puts you in a good position to be able to then go back and reevaluate the full life cycle of the ModelOps pipeline. Right? When you identify things that go wrong during production, that allows you to know that, hey, I need to adjust my data set perhaps because I've got a new category that's emerging, or I want to take a look at a new architecture that's emerging for replacing, say, my ResNet 34 with my ResNet 151 sort of model. Or maybe there was just a new error condition that emerged in production that was never encountered during your model training your model training efforts. Regardless of what the issue is that emerges, during production, when you're doing monitoring, you should be identifying when things fail, and you should be providing at least enough logging to allow compliance and auditors of your system to be able to evaluate how your model is functioning in the real world, and to be able to provide to your stakeholders any sort of performance metrics that they might be interested in along the way. Now, that pretty much completes the overall process that we put in place for MLOps. This is the same process that I walk through with our clients when I speak with them and explain to them how we think about moving from the lab off into a production environment. And so what I want to do now is take a second and share with you the way that we go about it at Modzy, how we actually transition from the lab out into a production environment, by giving you kind of a sneak peek with one of my staff members who's going to go through the process that I just outlined with you.
Hey there, I'm Douglas and I'm a machine learning engineer here at Modzy. At this point, I'd like to take you through the model ops process by building from the ground up a concrete example. Let's suppose that you and I have been tasked with building a computer vision classification model that can take in as input an image and determine what is in that image, as well as provide an explanation of why it thinks that. Using this standard example for a machine learning model, we're going to gain insight into what a well-defined model ops lifecycle looks like, step by step.
We begin the model ops process with the data science phase, which is concerned with obtaining data of sufficient quantity and quality in order to train a model that performs a particular task that provides value for your organization. So as we begin the process of selecting and training a machine learning model, we want to remember what our ultimate goal is, and that is to deploy this model into a production setting. Additionally, this is probably not the last time that we're going to have to undertake the process of building and deploying a machine learning model. So we're going to want to standardize as much as possible. With these two considerations in mind, we're going to use a model template. What is a model template? Well, simply it's a standardized abstraction for a machine learning model that is at the core of model ops. In fact, it is the model within model ops. So here at Modzy, we have an opinion on what this means and have our own model template based on our experience in building out an enterprise model ops platform. This is a template that allows us to create full-featured machine learning models. In its essence, this template provides a gRPC server that encapsulates your model and exposes its inference capabilities from within a hardened Docker container. We also leave the door open to add in auxiliary features, such as monitoring, drift detection, and explainability, all of which we support on our platform. The good thing is we have our Modzy GitHub organization here, and we have open sourced this gRPC model template. So feel free to check it out, use it, or simply use it as a source of inspiration. And to kick things off for this particular demo project, we're actually going to be using this template in order to create a new GitHub repository for our model. In this way, we can already satisfy all the boilerplate tasks of building out a production-ready machine learning model and get right into the meat of building and training that model. So let's get started.
So here we are at the terminal, and let's go ahead and create a new GitHub repository for our demo model based off of the template that we just saw. Now, using GitHub or some technique to version control the source code for our model is extremely important for ensuring the provenance of the model development process. This is particularly true for us as we're starting at the very onset of a project. And so that's going to be a huge benefit to us. Now, to create the repository, I'm going to go ahead and use the GitHub command line tool. And we can call our repo image classifier. And to specify our template, all we need to do is note that we would like to use the Modzy gRPC model template. And for the time being, we're going to create that repository as private until we're ready to open source it. And then I can just click through a couple of confirmations here. And it's going to create that repository and clone and bring that repository down locally. So we can go ahead and step into that repository, check out the overall structure, which, as I mentioned, is derived from the template that we saw. In fact, I can open a browser here, and we can go ahead and find our actual GitHub repository that we just created, entitled Image Classifier, and here's confirmation that it was generated from the Modzy gRPC model template. So at this point, I'd like to go over some of the core components of the structure of this template that we'll be using. And with this, it will kickstart the model development process. Let's get into it. So here I am within our image classification repository inside of my IDE. And to just highlight a couple key components of the structure, we're going to have our asset bundle, which is a directory in which we're going to store metadata about our model, how it was trained, what computational resources it's going to require in production, etc. Next, we have a package, Python package called gRPC model, as well as a directory called protos, which stores our protocol buffers, which are the API for our model. Now, if gRPC and that terminology isn't familiar to you, not to worry. This is a package that we've prepared that is essentially pre-built and enables the model to communicate effectively with the outside world. Of interest to everybody is the model library, which is a package storing all the code to train and provide inference capabilities from your model. That's what we're going to be building out here. So let's go ahead and actually refactor that package to be in line with the name of our model, which is image classifier. And with that, let's go ahead and build out the training and inference capabilities of this model.
In machine learning, high-quality, well-curated datasets are critically important to building powerful machine learning models. So for our task, I've sourced the ImageNet dataset, which consists of images within 1,000 different classes, which will allow us to train a powerful classifier. So to kick things off here, let's take a look at the file structure that I've created as I downloaded this dataset. And what I'll do is create a DVC repository, where DVC stands for Data Version Control, which will allow us to track modifications to the dataset and keep track of the version as it evolves. So let me go ahead and create that DVC repository here. And once that is initialized, we're going to go ahead and step in to the raw data and make sure that we add our raw ImageNet dataset to DVC for version control. This will take a quick second, but once it's done, we'll have all our data stored, versioned, and backed, and it's time for the training process. All right, now with the data set up and ready to go, I took some time to build out the image classifier package for our model, both with a source tree containing packages for doing drift detection, explainability, retraining, all using a ResNet 50 based architecture. So we can look in the retraining package where I have a script to perform training from a simple API. And what we're going to do is take a ResNet 50 model that was not pre-trained, meaning we're training from scratch, and we're going to train it on the ImageNet dataset that we just curated. We're going to do this for 100 epochs, so let's kick off the training process. All right, so this training procedure is going to be done on a GPU server, on an NVIDIA V100 GPU. And we've kicked off the process here. It's going to run for 100 epochs, and it's going to take several days, so I'll check in with you when the training is complete. All right, and I'm back after 100 epochs. We've completed the training procedure and obtained here, as you can see, a set of ResNet 50 weights for performing the image classification task. The second phase of the model ops process is the machine learning engineering phase, where considerations such as model robustness, security, scalability, and generalizability take center stage as we get the model into a state where it can be readily deployed into a live production setting. Now, since we're using a model template, we don't have to reinvent the wheel to get this model packaged and ready for deployment. All we have to do is follow the instructions provided with the template to fill out this single model.py module for our image classifier model. I've already done this, but what it consists of is using the weights files to set the model up to perform inference from within this image classifier class by loading the weights into memory within the constructor of the image classifier class, and then setting up two methods in order to perform single input and batch input inference from the model weights that we just derived from the training procedure. Now that our model is trained and packaged, we're going to go ahead and set up continuous integration using the CircleCI platform. To do this, from within our repository, all that we have to do is create the appropriate configuration files, which I've already done here. This will set things up so that commits to our GitHub repository will trigger a build and deployment of our models straight into the Modzy platform so that it is ready for production inference with one streamlined step. So to briefly outline the steps that I have set up for continuous integration, we see that I first check out the code, perform static analysis on the source code, then I install a Python virtual environment for the project with all the dependencies, and run the entire test suite for the model and the gRPC server running the model. Finally, I set up a remote Docker instance to build the Docker image corresponding to the model and use an internal piece of tooling known as the model importer to perform the model import into the Modzy platform. All right, so here I am in the CircleCI user interface, and we're going to complete the process of setting up our continuous integration. To do this, we'll simply create a new project for our image classifier model. And since we've already built that custom configuration file, what we'll just need to do is specify that we want our automated builds to run on a server with a Linux operating system. Now, with that, we can start building, and continuous integration is good to go. The final stage in the model ops process is our last mile delivery. This is where we'll get the software for our model into the production setting and begin to maintain it in order to leverage its insights to gain value now and well into the future. So I've just made the final changes to the model and pushed these to GitHub with one last commit. This has triggered the continuous integration process that we previously defined and executed each and every one of those steps here. That process culminates with an import of the model and its underlying software packaged within a Docker container to the Modzy platform. If we go ahead and click into that, we will see a link with the URL to the new model's model detail page within the Modzy UI. This is accessible from within our browser, and we can go ahead and open that up in order to see our model, a nice image for that model, as well as a transparent description of the architecture used, the data that was used to train the model, as well as how that model performed. We can scroll past all that in order to find ourselves at the bottom, where we see a couple of example snippets for an API request, which is how we can access our model within the Modzy platform and integrate this into our application, whether we're a front-end developer or an analyst looking to integrate ML capabilities into our analysis toolkit. So now that we've deployed our model, let's go ahead and use it. Here I am again in my IDE, where I've written a very small script to take advantage of the Modzy Python SDK and programmatically access the inference capabilities of my model by specifying the model ID and version for that model, and use my API key to submit images from my local file system against our image classification model in production. So here I have an image of interest to me from my local file system that I can simply submit to the production model, and in rapid order, we will get inference results classifying the object the model believes is in that image. So this is just a small example, and we're only scratching the surface, but on the Modzy platform, we can monitor that and our collection of models in real time and understand the memory and CPU utilization of these models, as well as use things like explainability and drift detection to monitor the actual performance of the model and decide when it is appropriate to retrain that model on new data. Finally, we want to have full insight and transparency around the model and the jobs that we've run, so we can go ahead and look at the complete history of jobs that we've sent to the platform for this model and all of our other models. Now, as we wrap up our time here in walking through the model ops process, we need to remember that this is not a linear process. It is cyclical, and all the insights that we gain from production monitoring and understanding of our model's performance through time will allow us to keep extracting value from it and iterate on this process, which makes it a true life cycle.
All right, well, after watching that video with Douglas, hopefully you have a better understanding of how we at Modzy go about implementing the model ops process that I just walked you through. However, I want you to remember that getting across the valley of death actually takes all three things that I discussed earlier on this afternoon. The first is teamwork. You have to have a group of people who are willing to work together for a common optimal goal, and even if that means pulling back on the individual area of expertise in which they contribute. Empathy. You need to be able to assess and articulate the return on investment from a stakeholder perspective in order to get the champions you need to move the obstacles out of your way as you try to move your model from the lab off into production. And of course, the model ops process framework. You need that in place to make sure that you can reliably and consistently move any model that you have in a lab environment off into a production environment. This concludes our seminar. I hope that you have found it useful and informative. And I think now we're going to go ahead and take some questions.
Thanks, Clayton. That was a great presentation. We have some awesome questions from the audience, so I'm going to go ahead and dive in. The first one is, what would you say are the biggest factors contributing to challenges crossing the AI Valley of Death?
Yeah, so that's a good one. Earlier in the presentation, I kind of talked about three things that were important for crossing the Valley of Death. I talked about teamwork, empathy, and process. So I think if I had to pick the most important things for each of those, I would say that on the teamwork side, it's probably talent. Most organizations don't necessarily have all of the talent available across the model ops spectrum. When you go to move a model out of the lab and push it off into production, at a minimum, you need a data scientist, a software engineer, a DevOps person, and some sort of IT person. And that's before we start talking about specialized people like machine learning engineers or site reliability engineers. And I think the biggest sort of holdback for teamwork is actually being able to assemble the correct team with the correct set of skills and not have someone who's just kind of going out and trying to learn, maybe how to build a Docker file at night or on the weekend on their spare time. So I think my advice to you in that regard would probably be to make friends with your HR department, because they are in fact the gatekeepers for your organization. And when you get the opportunity to go out and hire for these sorts of positions, they're the ones who are in kind of the best place to help you advance your goals by finding the right talent and help getting it through the door. I think on the empathy side, the biggest hindrance is probably a lot simpler than that, and it's just that as a data scientist, most people come to data science from some sort of STEM background. And regardless of where you go for that degree, from an academic standpoint, business just isn't a part of that curriculum. And so thinking about what stakeholders are going to be interested in and return on investment and those sorts of things, that's the sort of thing that comes with practice and just sort of exposure to industry. And so I think my advice for sort of overcoming that particular hurdle would be, as silly as it seems, to just simply go have coffee with the managers in your organization, because you need to be able to have sort of established relationships when you're asking people to spend their time, their people, or their money on your particular idea. And I think in the last part, in the process part, the biggest hindrance from my perspective is really that model ops it's a life cycle. This is not the same as software engineering, where we're basically doing one big thing and then patching occasionally on the first Tuesday of every month or what have you. When you are trying to be successful long term, you have to actually keep in mind the fact that you're going to continually be improving the model. You're going to be getting new training data. You're going to be finding bugs and those sorts of things. And so if you want to be successful long term, you need to be providing the information to your stakeholders when you're trying to turn them into champions, that you're going to need their help for kind of the operations and maintenance tail of this whole thing. And so you're not asking for them to help you right now. You're asking for them to help you today, tomorrow, and into the future, and providing them reasons as to why that's a good idea.
Awesome. I love taking the human aspect of that, because it's so incredibly important. Got a couple more quick ones we've got time for. What are the pros and cons of trying to build versus buy a tool that helps you build a model ops pipeline?
Yeah. So as someone who's spent the last couple of years building one of these things, I encourage you to go buy it. And I don't mean that super flippantly. The reality is that putting together a product, whether it's an internal bespoke product or whether it's a commercial product, that's capable of helping manage the model ops lifecycle, takes all those skill sets I was talking about earlier, and you end up in the same problem that I mentioned about talent and having a full spectrum of people available who have the capability of building these sort of model ops products along the line. But let's assume that you've got that for a second, and you're willing to put that talent to use in actually building something that's going to help you in your journey from the lab out into production. When you start looking at the opportunity costs associated with it, with taking those people away from meaningful external work, or not even the opportunity cost, but just the straight up labor cost associated with it, it becomes far cheaper and a far better business decision to go out and buy the products that you need, instead of tying up your personnel in having them use their expertise to build these sorts of systems and work through the long tail of going through and correcting bugs and deficiency requests and those sorts of things. So my advice is very much to buy it, because in the end you'll actually come out ahead.
That makes absolute sense. Got time for one more, and I think this is a very important one, because it's one that we're seeing a lot of concern about industry-wide. Governance and auditability are becoming greater areas of focus for my team. What are things we should be documenting and thinking about today?
Yeah, so this actually varies depending upon what industry you're in, because some are tightly regulated and they have different different demands on them, like say finance, for instance. But generally speaking, there are a few things that I think you need to make sure that you're recording as time goes by. One is your model and the model details and the history of that model, so that you can kind of take a look at the provenance of it while you're using it in production. And so documenting the model, but what you're using in terms of, say, architectures and frameworks, but also where your data came from, so that later on, when you're using the model, if it turns out there's a problem with that data set, you'll know which models need to go back and be adjusted and looked at. I would also encourage you to put together a set of performance metrics for your model that you know on the front end, and that you can compare against on at least an annual basis, so you can identify things like concept drift, and identifying when inputs are coming in that just simply are no longer applicable to what the model was built for. So I think kind of a good example of that would be a credit risk monitoring or a credit risk model that was built in 2007 would not necessarily have been applicable in 2009 after the crash. So you want to be able to just at least periodically take stock of the models you're using and identify when the outputs no longer make sense given sort of some controlled inputs. And then I think on sort of the auditability side, the two things that I would really encourage you to take a look at are important in production, but we didn't necessarily directly address them. And those are explainability and drift detection functionalities. If you take some time and do some Google searches and look out there, there are a few different capabilities that have emerged for explainability and different thoughts on drift detection. But at the end of the day, what they tell you is that, on the explainability side, what that's telling you is that whether or not your model is functioning in a way that you would expect it to function. Given this input, did it produce a useful output? And drift detection is telling you whether or not people are using the model in a way that you would consider to be consistent with the design of that model. And so whether or not the inputs being provided to it make sense from your perspective. And so I think collectively those sort of four things: documenting your model provenance and test data, taking a look at performance metrics and keeping them up, as well as explainability and drift detection. They go a lot. They don't get you all the way there, but they get you a lot further for your governance and auditability concerns than most people today have given much thought to.
Well, thank you so much, Clayton. This has been an absolutely wonderful presentation. I know I learned a lot, and hopefully all of our audience did as well. For those who want to rewatch it, you will be getting a link for the on-demand version. Keep an eye out for that, as well as a quick survey just to let us know how everything's going. So keep an eye out for that. That'll come in tomorrow. And if you have any news, please always feel free to reach out to us. Again, thank you to Clayton and the Modsy team. This has been a wonderful presentation, and we look forward to seeing you next time. Have a great day. Bye-bye.